So, today we're going to talk about the event flow and maybe more things around it. A few bits about me. Well, software geek, I like functional programming, and pragmatic purist. That's me. So in this talk, we're going to review elements of CQRS and event sourcing system, look at how can EventFlow help as a tool to both prototype and maybe to, well, in some future, run the system. And yes, everyone is invited to participate. Feel free to raise your hand, shout, and, well, just let us know if you want to add, ask, or comment on anything in the talk. Don't wait for the end. So the elements of event sourcing are, well, starting with event, command, aggregate, and command handler. There are more, of course, and we'll see a few of them, not all, in this talk. What does event mean? It just happened. I know it happened, and I can't change the fact that it has happened. It's just a message read. And this used to model a state change. Not a state, but a state change, like some delta. If I had a counter of 1, and after I had a counter of like value of 2, then the event is not changed from 1 to 2, but most likely it's increment by 1. The commands, on the other hand, are messages to make it happen. It's a request. And the user can ask a system to do something that is going to be a command, that is going to be validated and hopefully transformed in a sequence of events, like deltas of the system chain, like of the system. So how do they happen? Where do they happen? Where does it happen? It happens within aggregates. And aggregates is really just a consistency boundary. It checks that within its boundary, all the business rules are true at any point in time. If I request a change, an aggregate will read all the past events or get that same information in other ways. We'll check if it can execute the command, and only then it will produce events. Otherwise, just an error.
So is an aggregate a question, or is it a question and the command?
So the aggregate, generally it's a consistency boundary. It's something you model that all the things within, it's a set of business rules, more like that. It's not something you can necessarily define, well, as a piece of code. I'm sure you can. We will see how. But it's more like a term, like a logical understanding. Like, for me, it gives an understanding of what rules depend to what unit, and that one unit that composes those business rules is an aggregate. Did this answer the question? Yeah. So command handler is a specific part of the aggregate. It's more like a technical term. It's that part that accepts command. It accepts and validates according to the business rules described for the aggregate. So functional form of it could be, if I have a list of events and then I pass a command to that, I get events, new events, or an error. So later on we'll see an example where I model a simple counter that cannot go below 0. And it is that within command handler, it will actually check this business rule. Projections are the pieces that live outside of an aggregate. They read all of the events that aggregates produce for different aggregate types, which is another way of saying, like, if we have an aggregate type of a counter and two instances of a counter, counter A and counter B, they're going to be different aggregates but same aggregate type. Another example that I have is doors, and doors would be another aggregate type. Different door instances would be different aggregates. So projections are used for users to see the state of the system. They're transforming the events, the deltas of the system, to some data that they maintain internally that is comprehensible by users, that gives the reason to use the system, the kind of, I see an output. Like if I have a computer, a keyboard is where I send commands, the display is a projection of all those events. Another projection could be like printer, audio output device. Now, my wife said it is the worst diagram I've seen in my life. I tried, I really tried. So if you put all those parts together, and there's another bit I haven't talked about, you get a system of aggregates, and there can be different blobs that live within your system, and they're all ensuring that they're strongly consistent within their bounds. So this blob is always correct. The business rules there are always ensured. When I send a command, it checks with the past events that it has had and produces new events, two projections, which then send the data back to the user. Another kind of, well, events also go to sagas, or like process managers in other terms, that can automate users, send more commands, and such the system will kind of live. But all as a sum of parts of those components. Does it make sense? Yeah? Okay, so it's not as bad as my wife told me.
So it's similar to MVC in a way. What's the difference?
What's the difference? So in MVC, I have a model, and your model would be all of these aggregates. Then you have a view that reads from those models. Now, I guess the main difference comes from CQRS versus MVC. So that these projections can have their own state. They maintain the data. And the data that is sent to customers is not necessarily, and usually not, one-to-one mapping to what's in aggregates. Another part is that when I send a command, I'm only affecting a part of the system, so it's usually, well, it's not really locking the world, where, well, it's not a rule in MVC. You can actually also lock just a sub-part of your system, but in this case, you have a specific unit that you know about and you care about. And everything is really done via messages. So a command is a message, an event is a message. It's more like message-driven communicating blobs rather than something that lives as a model and then the view part and then. Does anyone want to add anything to this explanation?
When the MVC is supposed to be synchronous, while CQRS is supposed to be asynchronous.
Okay. So MVC is supposed to be synchronous and CQRS is supposed to be asynchronous. That's a good point.
So how's the aggregate different to the read model? Because I guess conceptually, like, this seems similar because obviously they both kind of aggregate things to an extent.
Sorry, can I repeat?
What's the difference between the aggregate and the read model?
What's the difference between aggregate and the read model?
Yeah.
So an aggregate is more like a write model. It's something that you send commands to, and it ensures that the business rules implemented within its boundaries are enforced. Now, read model, that would be more like a projection, where it has data, it reads from like events happening outside of that projection, it updates itself, and enables data to be read by user. Did I understand it right?
I think so. So like it's an aggregate is like the boundary through which you access things, and it goes and ensures consistency in it. You can
It's more like telling, not accessing. Telling is part of accessing, but you don't read usually from aggregate. What users read is usually flattened data. Like if aggregate only produces and lives on events as messages, those events are only flattened in projections. So that's your read model that's relevant for users for a particular use case.
There are multiple models in DDD, so an aggregate can be considered a model independent of all others. Bounded context can be considered a model, and the whole view there, the whole collection there can be considered a model, depending on the view.
Yes. So there can be different, many projections and many aggregates, and they can be grouped to bounded context, to an area of the system that you particularly care about in this context, like this business unit, for example. And it could communicate with another part of your system that is another bounded context. And there would be translation there in between. Is that what you meant?
Yeah, just that with MVC you have one model necessarily.
Yes.
And you're never going to break that down. It's sort of fairly monolithic in that perspective.
Yeah.
And that model is specifically to serve a view, whereas this is the domain model. And it's your projections that will provide you kind of your mashup of a model and a view in that respect.
Yeah, I think you're right. And just to repeat for the microphone, MVC usually just has one model as a monolithic application view of all parts, whereas you'd have different use case dependent models in your business, like depending on business units. Okay, any more? All right. So EventFlow. Given all of that, I hope you don't mind a bit of Scala. If you need an explanation, just shout. I'll explain what it does. The counterexample that I mentioned before is simply, it's consistent of event, which can be created. I can create a counter, increment, and decrement. And same with commands, which in this case replicate the events. However, it doesn't have to be the case. It could be different. And the systems evolve, they are modeled differently. And if I spend more time, I could even use different names for better meaning. Is everyone okay with some Scala like this? Yeah? Let me know if there's any question you have. So this is considered as one structure, one ADT. So event, like everything that extends event, like this sealed tray, is considered like a part of like event. Event can be one of those things. Same with command.
It's a little bit like a C header file.
Yeah, except that this is actual code. So the aggregate model. So EventFlow, a bit about EventFlow. The usual approach of object-oriented approach to event sourcing, and it's like DDD, there's entities, aggregate roots, and so on. I haven't talked about them, and I won't, because EventFlow doesn't use them. It tries to model your system, your aggregate, as a state machine. And, well, know what state machine is. It just is a list of different states, and depending on the input, it can jump between states, back and forward. Now, I would call it finite state machine, but it can accept parameters, so it's not really. And it starts with aggregate logic. It has one handler. When there's a create command, it just doesn't check anything, because there was nothing before. Then it emits created event and switches to counting based on the start. It passes the start, the value of the start parameter, to the function counting, so our C here will become that value. In this case, it's an integer, and when being in this handler, I receive increment command, I will emit incremented event and switch to the same function of C incremented by 1. When there's decrement, I will put a guard that C has to be more than 0 for it to be decremented. Otherwise, I'll just fail. But if it is above 0, I will emit decremented event and switch to counting C minus 1. Is that more or less clear? I know the code around this could be simplified a bit. This was some unfortunate complexity I had to add for snapshots. I'm still thinking how to simplify it. We'll talk about snapshots later. It just tells here that our counting function is snapshotable. So whenever we switch to counting, it will snapshot it. And when an aggregate gets the next command, it will restore itself from snapshot, both the function call and the parameter. Another bit that when I'm in counting state, you see there's no create command, and in aggregate logic there's no counting commands. So they'll just fail by default. They'll fail no handler found for this command. Or you could add a specific handler and add a message, add a custom message if you want. I guess it's all clear, but judging by the silence. So let's continue. Doors, another example I mentioned before, has a similarity for events. One difference here is that locked and unlocked events have parameter. What key was it locked with or unlocked? And commands follow closely the counterexample. The aggregate is slightly more complex. I haven't included the wall surrounding bits. It starts with, I believe, open doors state, and you can see that you can only close the door when it's open. It will emit closed events and switch to closed doors. When it's closed, you can either open it, we'll do the same, or lock it. When switching by event, you see that there are different constructs, switch and switch by event. You have the event as parameter to the lambda here. So you could extract a key from the command and pass it to the next function. When it's locked, you can unlock it with the same exact key. So when it's passed like this, it's checking the object equality. So if unlock command with this key is the same as the command it got, then it will emit unlocked and switch to closed doors back. Otherwise, it will fail with the message. So any other unlock command that didn't match the first matcher will fail. And this is an example of how to add a specific message when a command is not expected. So if I try to close the door here, it will give this customized message this time. Any questions?
Does this mean like you'll always aggregate your you'll always model your aggregates as stateful?
So
or you put it then as stateless?
So these functions are really stateless. They're just recipes for execution. They don't hold the state. All the state that they have are coming from parameters to the function. So if we see the counter, the state is here. In implementation terms, if an aggregate is not snapshotable, like the first version that they did, it would replay all past events and will try to match them by the increment, by the emit handler, and will switch accordingly. There's another way to do that, which we'll see, but essentially, these examples are really just recipes for execution. They're just description of the rules for the aggregate. And the state is really modeled by events, like past events as deltas. Any more questions? Okay. So EventFlow has a kind of DSL. If you're interested, we can talk later about, it's not in the slides, but we can talk later about the actual implementation. Here I've included a high-level overview of how to use it. And that's, as you've seen, it doesn't give nice examples here, but any description of recipe for an aggregate rules can start with either command handler or event listener. We'll switch to event handler and can loop, so you can define many of those. The first matching will be applied. Command handler starts with either when and command type, or when and specific command instance, which would be checked for equality, such as we have seen with unlock. Can have guard or can omit it. And then there are different forms of emitting events. You can emit event type if it doesn't accept arguments, or actually this one, if this one will try to copy all arguments from the command, even if they are different types, but if they have same argument sets and same types, it will copy those to the constructor. This was the first external contribution to the project. So thanks for Mark. Emit event type. You can emit a sequence of events, so you just list them as comma-separated values. You can emit given a command, so if you have a custom event builder given a command, you can do that. Or same with multiple events. DSL for event listener, it's simply on this event, and then it switches to the event handler where to switch. This event listener is optional. EventFlow will try to detect it from your command handler and then event emitting, like which event you emit. But if that's missing, you can add on these events. I will switch to here. I can omit the switch sentence if the aggregate really stays in the same. And switching requires another function to pass to, a function of the same type, which is the flow, like a counter that accepts an argument or so. Switch by event, you can do it a bit more dynamically. So, any questions about the DSL? Any suggestions? So, as I mentioned before, reading all events that happened to be able to execute a single command is very slow, and it's not very scalable. I find it fast at the start, but later on you will see it's just looping forever. That we have snapshots, which either at time intervals or number of events, or just every single event, just snapshots where the aggregate is now. And when the command comes next, it will restore for them from that snapshot without reading all of the past events and folding over. So this is the purpose, which I have just described. And yeah, just could be thought of as cache. So how do they work in EventFlow? As you can imagine, serializing a function is a bit difficult, at least in Scala. Or I didn't find a nicer way than to just register a pair of a symbol and a function. So as we've seen in the examples, we have a symbol, which is a reference, and then the function. And this symbol is only needed for snapshotting. So it gets that symbol and all of the parameters, and then serializes that to a metastream. Restoring then is simply just look up a function that is registered for the same symbol and apply the serialized parameters. If you change the logic during the lifetime of the application, it is better to also change the symbol and keep the original symbol still available. So there are some bits to resolve regarding that, like how does it change over the life of the application. Any questions about snapshots? Does anyone have suggestions how to improve the symbol function pair? Well, if you do, let me know. So, projections in the counterexample. Say we need to know what's the current state. Like, yeah, there are all those increment, decrement. What's the current state as a number of a particular counter? Or even to find all the counters in the system, if I create them and increment and use them, how do you list them? For that, there's a quite simple projection. At this point, I just used an in-memory tree map of an aggregate ID and an integer. It listens for counter aggregate, and when there is an event for, well, these aggregates really as a type, with that ID, I just update my tree map. Initial data is empty. Is it clear? Well, I hope it is. The plus sign here is kind of Scala's tree map functionality, which just means update given this key and that value, and it will either insert or replace. And D is the original projection data. So again, it doesn't hold its state here, it gets it in the function. So Door's example is slightly more complex only because integer is not enough. To know the Door's state, I need to create another structure. Is it open, closed, or locked? And it's completely different from the aggregate structures. It's completely different from events and commands. It's the read model. However, the logic of the projection is, again, quite similar. I just change the state of a tree map in this case. Also, projections can read events from multiple aggregate types. And I was a bit surprised and quite fortunate that Scala supports this kind of syntax. I can simply match different types of the same structure. However, this is possible. You can specify multiple aggregate tags. This will let this EventFlow know what to feed to the projection. And you can implement your matches for those types, for the event types. Right. So any questions about projections or EventFlow implementation of them?
What's the tag thing on the counter aggregate?
The
Is
tag.
that the specific tag name, or is that?
So a tag is, well, it's slightly in kind of implementation detail of EventFlow. However, it's a value that is getting constructed when you define your aggregate, and you can use it to specify it here. So, for example, when you, it can be, well, it is also serialized when you push to event store, for example. You can.
Can we see that directly in the counter aggregate definition? If we go back to the aggregate definition, how do we?
Don't think you will see it in the aggregate definition because it is constructed implicitly. However, you could override it. You could specify one that will override the default constructed one.
So is the tag more a case of saying which events I'm interested in?
Yeah, it's more like a tag is a serializable tag for the type of an aggregate. So all counter aggregate instances will have the same tag by which I can know that this is counter aggregate tag.
So it's just something to put it in the depository, like unique.
Yeah.
Yeah.
Okay. Yeah.
So it gets from depository the value according to the tag.
So when projections,
Repositories.
yeah, when projections are read, it's again depending on implementation. So far, I have two implementations: one in memory and one at event store. So the tag is put to event store, for example, and when a projection is subscribed to event store, it gets the tags. Then EventFlow can compare the tag. Is the projection listening for this tag? Yes, no, I'll feed the data or not.
So it's kind of like just saying type. So it's a list of counter aggregates, but that's
Yeah.
just a way of phrasing it in the DSO.
It's listening for a list of aggregate types. So a tag is simply a serializable tag for that type. It could be named as type, but that would be not really working because of the reserved keyword. I could potentially rewrite this to even omit it so that it just pulls it automatically. I might try that.
So is this, it's more like a shortcut for saying this projection is interested in listening to events coming from the counter aggregate.
Yeah. Yeah, exactly. I'm listening for counter aggregates. And if the system contains more aggregates, such as doors, this projection will not get any of the door events.
Does that mean each event can only be emitted by one aggregate?
Each event,
You're listening to a specific aggregate rather than a specific event.
do you mean if two different aggregate types can share event type?
That they emit.
That they emit.
Not the one that they make decisions based on inside the consistency boundary, but one that they emit.
Yeah, I don't see reason why not. So defining aggregates would be possible. They would be working. Defining projections would work in most of the cases. One thing that I'm not sure at this point and would need to check is what if you listen for different aggregates that use the same type, what happens with the matching here? Because you match by events here in the function. So it would just probably work. You would match for both aggregates with like IDs different, but then how do you know what you update? You can't match different aggregate by the same
You might
event.
not care which aggregate.
Yeah, if you don't care, then it should work.
Presumably, if you kind of separate your domain concerns, like model your business domain, so one aggregate will emit particular types of event by definition because it's in charge of this type of functionality.
Yeah, at least if not, I can't think of an example when it should be required, but it's possible. I don't see a reason why it shouldn't work. If I think it's included in the example, when you're defining an aggregate, you specify that EventFlow is for this event type and this command. The reason it's called event and command is that they're living in the same kind of object already, so there's no clash of the names. They live in a package where only one event type is available. And this is illustrated by example when both are being read. So door.event versus counter.event. Okay. How do we go about testing aggregates? Do we need to test? Who thinks we need to test? Okay. It's like about a fifth. Well, I think we need to test, yeah. However, the tests should be easy to read and easy to write. It's rather common to see the tests that start with given. Prepare the state, given something. When something happens, that's where your action is usually. Then I want to check something. Sadly, I couldn't just use then because of the reserved keyword. An example of a written test for a door is that given I have a new database with events, door is registered, closed, and locked. When I request a command for the door, the same door, to be unlocked with the same key, then new events of that aggregate door should be unlocked with the same key. Well, honestly, I still kind of try to think of how can I remove those braces. Maybe I'll come up with a way in the future. But so far, what do you think? Is it readable?
Spoke.
Sorry?
Like spoke.
Like Spock.
well, looks like Spock test. And then Spock can do it.
No, I haven't used it. So, do you have any questions about testing?
Why did you use the word should?
That's not my keyword. That comes from a framework that I use in this example. So this test runs with Scala check, I believe, or Scala test. And this is just a should matcher of that framework, where, well, should be, actually, be is also another construct of that framework, and they give it a value. The parts of EventFlow are given, new DB with events, when, command, then check new events. So those are specific to EventFlow. This is customizable by the framework of your choice.
So it's just a framework, a keyword rather than actually
Yeah.
an image.
Yeah, and in this case, it's actually, well, not particularly to my liking because it's probably an exception on error. I'm more like a functional kind of guy. So I might want to look in future how to replace it with more functional style tests, like declarative, well, with execution. But yeah, this was my first attempt. Any more?
Do you have other functions other than check, maybe then throw for failure scenarios?
There are other things. Don't remember exact, but there is exact term, but there is a case to check, for example, a command has failed. Like a command should fail with this. But yeah, there is that. Okay, I'll go further. So the current state of EventFlow, there's GitHub, there's Gitter. In Gitter we talk about few things. So currently, as I mentioned, it supports 2 database backends. In memory for just quick run. If you want to prototype things, you can launch it. Or there's get event store integration. I don't have any more at the point, but I didn't really need them. If there is a need, it's not that difficult to add them. Front-end example. So I'll scare everyone, if it works, with a piece of code as an example how to integrate it with a web framework to provide an HTTP API. Now I wonder, where is it? Oh, it's loading. That's, of course, if the internet allows. So this is the entry point. Well, this is all the code that is needed to create an HTTP service out of example. That's 77 lines. If you remove the braces, it should be less. There is one function that is shared across many of those, is a command endpoint, which simply translates the framework language, where I get the ID and serialized command. There is some future magic, and this is where we call the actual EventFlow. We say database run aggregate, where aggregate should load and handle that command for this ID. Now, what is database? A database is, well, an instance of a database connection with some registered projections. So at the point of constructing a service, I specify which projections should it run and which database backend it should use by just using correct constructor of the database connection. Counter endpoint is rather Simple, given that function. I specify the endpoint, and I specify the aggregate. All the mapping is just glue code here. Projections are slightly more difficult by the fact that different projection uses the projection data differently. So if I request a specific door, I have to extract a specific door by ID, or if it's multiple doors, I have to just return the list of keys. So I hope that wasn't too scary. Do you have any questions? Good. I opened it twice, and then it's gone. No? All right. Where is it? Do we have time for demo, or should I just talk through it? Well, essentially it's just using that service that we have just seen, the counter and doors. I'm using an HTTP client tool called HTTP-E, which simplifies usage of it, so it's possible to do with curl, would be a bit more complex. I'm just sending post commands and get for projections. When I said, well, it's in JSON format as well. If you're interested, we can go through it, or we can just skip it.
How long is the demo?
Sorry?
If it's how long is the demo? We can watch the demo. If it's not very long, let's see the demo.
Well, the demo is actually trying to use it over this internet connection, so we can. Why not? If it fails, it fails. So, it's deployed to some cloud instance, and when I request all counters, it gives me currently existing counters. And if I copy command to create another counter, well, let's try to create counter A. Hopefully it fails. And it did. I could work on error formatting, but it does tell that it cannot find handler to create A. It is currently in a different state machine state, and create is only available at start for that. So I'll just change an aggregate ID and create aggregate D. It starts at 10. It's just created. I can confirm it by requesting all counters projection, and I can request its value. Like that. It didn't fail. I didn't try to increment. Should I try that? Yeah. It might fail now. So counter D increment true. It succeeded. It's 11. Oh, another bit. What if we try to decrement it? Yes. Multiple times. I'm not counting. I hope the server can count for me. Ah, here it is. It cannot be decremented because it is 0.
So was it going faster when you were decrementing over and over again because of the snapshot?
Just internet.
Oh, okay.
It's 4G. There's a similar example with doors. Instead of going through that, I'll just show recorded session. As you see, I'm calling similar commands. It's saying, yes, okay, I can register a new door, will be golden as key. I list the doors, and here there's A. I list the door A, and it's currently open. I close it. Yes, that's fine. I can close it. I don't even check it again. I lock it with golden key. And check. It's locked. It doesn't tell me the key. I try to unlock it with a rusty key, which it says no, can't work like that. I have to use golden key, where it says fine, and changes the state to closed. Any questions? Was I not too fast? Should I return? Yeah? Okay. So the future is, we've not talked about them at all. And the main reason is because they're not implemented, they're not ready. I believe any system boasting that it could run live should have monitoring and APIs for that. So there's none of that. There's a lot more ideas in GitHub issues represented as a board using this tool. If you have more ideas, just add a new GitHub issue. They will appear on the board as well. So given this, how do we implement a domain model from scratch? Like, yeah, it's like, I've seen this. So what? So I believe that the first thing you would do is to define your aggregates, the boundaries, your rules. What should the system do? What should it care about? What should it enforce? And a good tool for that, well, I found this event storming. It's just like process of lots of people and stickies, but you do get lots of information about what you're building from it. Again, system that just writes and executes, it's not really useful. What do clients expect to see? In what format? Projections can become complex, like searching, like push data to Elasticsearch, push data live to customers' mobile phones, and silence. So we've seen some components of a generic CQRS and event sourcing system, the way how to possibly do that with EventFlow. Some examples of how it is done. And yeah, there's GitHub and Gitter that I invite you to visit. Join. Everything, any input you can have is welcome. Code reviews. I believe code should be a bit nicer. I do need ideas where to start though. Adding more code, adding ideas. Just chat. Yeah, why not? And thanks to DDD Europe, we also have a t-shirt. There is a question. So, one thing that we haven't talked much about are sagas. Who can explain what sagas are in detail?
What size is the t-shirt?
That's, I guess, a question to Arturas or Daria. Are you thinking to raise your hand or not? Yeah.
Sagas are processes that go across bound context to effectively involve or aggregate routes.
Okay.
So they're obviously harder to synchronize, or to be precise, it's hard to keep this thing consistent because of that could affect multiple aggregates at the same time. Or they could affect multiple aggregates.
So it's a process that goes across multiple bounded contexts and reads events from different aggregates.
When we're reconstituting them.
Sorry?
When we're constituting them.
When they're constituting. Okay? Does everyone agree? Yeah? Okay. I would simplify it, so an automated human. But yeah, congratulations. I hope the t-shirt size fits.
So if you have a next question.
Okay. The t-shirt size is M.
Yeah, it's going to be right.
And apparently we have a bag, so now I need to think of another question really quick.
But we can ask a question.
Sorry?
We can ask you a question.
Oh, you can always ask me.
Okay. So just wondering, one of the biggest selling points of DDD was like this ubiquitous language, kind of, so you name your concept, like classes, like functions after concepts in the domain, like business concept. And so you can even go to business people, show you code. And so I'm just wondering if it's somehow a little bit goes away from that into a really technical kind of all these event sourcing, like, I mean, would you go to Scala, with Scala code to your
So this talk, yes, this talk has been strongly focused on the technical and infrastructure part. The big part that we haven't discussed is indeed ubiquitous language and understanding the business concepts. And you have to do that first, really.
But also, if some, because you said event is a change in the condition, so if business people don't see everything in terms of event, if they also see some other things like state or, so how do you, not just events,
How do I...
do you do this?
Well, that's a good
Or you
question.
force them to think in terms of events only?
What is a state?
Well, a
So
starting state or?
Don't they just see the system as a stream of events and a black box?
Yeah, like when I come to a computer and I do something.
Well, it's not a computer, it's you solve a problem, like real problem in life. And
Okay, so that was a bad example. See, we have a library. There was an example that we did recently, and a book is checked into a library. So what changes? State changes. There's change of the state. So what we do is we record that change. There were all the books in that library. I added one. I checked out one. If it's also a shop and the library, and then I checked out one and paid, and don't expect it for it to be returned because I just bought it. So other people can there might be different events, different changes. However, the state is minus one book. Did that answer the question? Yeah. Okay. Yeah.
One thing I'm interested with event sourcing or I guess it's just event sourcing, isn't it? With the event system is, there was a good example I remember that Greg Young told me that he was saying this is really good for like partial connectivity. So I guess, because could you, with this system you built, would it be much easier to build an offline first application because you could replicate some of that aggregate thing, say, in your app, and then you could obviously put up the events you do while you're offline, and when you get back online you can send them all over and you can work out at what points you got there. Is that something would be easy to do.
It is possible, and it's, I think, definitely easier than if you have just two mutable states.
Yeah.
But you will still need to do additional work when you have to join two streams. And that's your business specific. How do you join two events that have happened independently? If they're different aggregates, then fine. But if you have the same aggregate split with partial connectivity, that might be harder, and you would need to figure out how to do that within your domain.
Would that be like, would an example be like two people working on a document, like spreadsheets? Someone might change. I guess you need a way to resolve that conflict, don't you?
Yeah, exactly. So yeah, what if we are at the same position? I inserted letters A, B, and C, and you removed two letters that were before and added D, E, and F. What should be applied first? And yeah, and then another question is how to communicate that back to the customer. Before merging our two versions, I had the original text plus ABC. We had a different text, but then when our systems reconnect, it changes. Like, why? As a user, I don't understand. So somehow that communication also needs to be made clear. It's slightly more complex than not having to deal with it. Well, it's a lot more complex than not having to deal with it, but it's at least, I think, possible in many cases if you're comparing like with just stateful systems.
I suppose it's better customer experience if they can do something when they're offline rather than explain to them a conflict, saying we can copy your work up to now. It's better experience than saying, okay, we're offline, we can't do anything.
Yeah, true. Any more?
I have a question. On the creation of the aggregate, that effectively inherits from, that makes sense, EventFlow with a set of commands. So effectively you're merging together what usually are two separate components, an aggregate and a command handler. In this case,
Yes.
there is always replaying previous events before applying a command.
That or from Snapshots? Yes.
That or from snapshots. So effectively, there's no, if the command is wrong, like in syntax or anything else, that still queries the database.
It's accepting command that is already in a form of ADT. So I assume you could deserialize it already and maybe validate the simplest rules that don't require those events. So that you could do that before requesting it for to be run within the aggregate.
Okay.
Yeah. Any more?
How are you capturing the snapshots?
So the snapshots are here just the symbol that is paired with the function of the state and parameters given to that function. I can serialize that. And then I store it like in an event, get event store case into meta stream of events, where I can read it back from. And from that I can look up the symbol in the list of symbol function kind of table. Whoops. And first find where I'm going to apply it to, then unserialize the parameter and just apply it.
So the symbol is stored as part of the event or the event store?
No, the symbol is stored only to the snapshot. It goes to meta stream. So you have, like in event store, you have stream for aggregate events,
Yeah.
and snapshots are separate information from that. It's a meta stream.
What's calling you to do this? Was it a particular use case, a particular thing, or where did it come from?
Honestly, it was initially a motivator to learn Scala as language. And yeah, I thought, why not this, kind of. And then, when I had something almost working, why not adding that too? And then, hey, what if I do event storming, I could prototype my structures like really easily as like this state machine. And that kind of led to continuing even more. And of course, people who join Gitter and say, ah, this is nice.
From your experience, like how hard is it conceptually to do events this kind of system? Because I understand the benefits. Like what you can do is quite amazing. Like say for example, you had like a user table, and the business says, oh, we want to know when they last logged in. It's like, okay, we'll add that at the beginning, update the thing. It's like we want to know the last 3 times they logged in. So as things come up, you can obviously make sure if you've got the events for it, you can tell them anything they want to know. But it seems like there's a lot of effort to invest in this, and I guess
it depends.
Is it always worth it? I guess is the question.
Is it always worth it? No, of course not. It's slightly more complex than just a MySQL table or whatever, or like Oracle, if you prefer. And it's definitely more complex than kind of just a database view, like CRUD system. If that is enough for you, yeah, why not? Just use it. Keep backups every day. Like if anything happens, so you can come back to see what states was the data last month, as long as you keep that backup.
What about hybrid things, like where you say you had an existing application that was that had tables, but then you start recording events because you might want to know how did things get to a certain point, like how did this customer get basket messed up?
Yeah. So this is one of the reasons to use it, like event store. It's kind of you really just store the transactions, deltas in the system. So if there's a case of like conflict resolution, you can go back and see what actually happened, which wouldn't be really possible with a database table-driven architecture. Another thing is scalability. So CQRS especially is, so databases, what are they optimized for? For everything, reading, writing, but none in particular. This is using append-only data stores, so just throw new events to at amazing speed. And projections, they just grab them as they come, update their state, and then show. Those projections could use your tables. Like you could update actual database tables, not just in-memory maps as an example. So that's another reason. Did this answer your question? There are many reasons.
Yeah.
We can cover a few, but we can discuss more.
I think the thing I've realized with all this stuff is very challenging is like software design patterns. Software, this kind of design is very different to say learning like a factory pattern or like, because you can learn that you go, I get that. And this is kind of like, reminds me when I was in university where you could do like, there's a maths section, they teach you how to do something. It's like, yeah, I get that. You do an exercise, it's like, hang on, I don't get this, and you work, you do your tutorials and you get it. And I feel like the only way you can really get this is not by going to talk. You actually, after talk, you have to go and okay, apply it to a problem. And it's only that seems that's the only way you can actually understand how it works.
Yeah, definitely learning by practicing is the best way to do it. Right. So we also have apparently a bag. It's not bad. And there's a question for it, if you can explain what eventual consistency is. Because I've only talked about strongly consistent components. Where does that come in? It's not bad.
I know it, but it will be unfair. Go for it, guys.
Yep.
Comes from the graph theory. You can only have either the system can only have 2 parts of the variable. Either is like speed,
Yeah. Maybe I'll go back and find it, my super nice diagram. There it was.
A t-shirt with this button.
What could we say is eventually consistent in here? Like in practical terms. The last bit here? Okay. Anything else?
It means that you will see different data because you can ask to do something. You can execute commands, but your projections can be slightly delayed.
Yep.
So you will really see different data. You can see different data at the same time.
Yep. And yeah, it's really these two arrows, the events going to projections and silos. So I guess we have two right answers. Well, three because Capvium is correct to you. How do we share? Okay.
Cut into 3 parts.
Any questions?
Where's the pub?
So the pub, I believe, is around the corner, someone told. And it's called Fox. Yeah? Shall we go to the